So Ford Smart Charge. This starts out with the common features, soft start. Remember, it was built into the regulator for GM and Hyundai in the beginning. But for Ford, it's commanded. 3 to 5% duty cycle. I almost always see it exactly at 3%. I know their spec is written as it's 3 to 5%. So it's soft start command, meaning when you first go to start the car, the PCM immediately sends out a 3% duty cycle command to the alternator that says, hey, don't charge. It turns the alternator on, but it's like at 11 volts. It's basically not on at that point. The load response control is built into the regulator just like it was for all three manufacturers. And it has its fail-safe charging, which means if you disconnect it, if you just unplug the connector from the alternator, start it up, rev it up, it's going to charge at about 13.8. It's limp home mode. The signals for it, the Gencom or command, it's roughly 125 megahertz. And once I go through about 2 slides here, I'll tell you exactly how the Ford works. The Ford is the least understood, my favorite of all the systems, but I'm kind of a Ford guy, so you can't really. But its frequency actually varies what it commands at. It commands 5 to 95% duty cycle. The more it commands, the more it wants. The 2 bottom lines here are the 2 that are important to remember for Ford. The regulator outputs 12 volts over the Gencom circuit as a source voltage. So if I'm the PCM and you're the alternator, the line I talk to you on, you push voltage up at me, and then I'm going to manipulate it. It's not like the GM was where everything went out of the PCM. The actual source voltage comes out of the regulator, which is it's very unique. It's the only system that works this way. This bottom line is the most important thing to remember when diagnosing a Ford. The command is only present when it wants a change. So if the alternator's doing what the PCM wanted, it just quits talking to it. And that just kills guys because they'll go up there with a voltmeter and stab that circuit and go, there's nothing going on. You got to go in and flip the headlights on, or you got to do something to make it issue a new set point command, or it just doesn't talk at all. The feedback line, duty cycle chart. So this is just like the GM chart we looked at, right? The bottom end is a failure modes where it monitors it or commands it in this case for soft start, and then the normal operating range. The Genmon or the feedback line, the 2 things that are important on here, it communicates the language. The voltage comes backwards. Did I put that up there somewhere? Oh, the PCM outputs the voltage. So where you're going to talk to me, I push the voltage down to you. Then you manipulate that voltage. It's what makes the Ford system so unique. But it does communicate the language too. So as we zoom in here back to this screen, here's the schematic. I'm going to zoom in on this portion of it. So here's the communication between the 2. So on Gencom, or the PCM talking, the regulator's pushing voltage up. The PCM manipulates it into a duty cycle and sends it back, right? The monitor line is the opposite. The PCM's pushing the voltage down. The regulator manipulates it this way. So here's the way I explain this to technicians, because this is the most misdiagnosed system or least understood out there. Is if I'm PCM and you guys are regulator and I want to talk to you, you push voltage up to me, right? Gencom. You have your own voltmeter and it's tied to that wire and you see it as 12 volts until I start talking. Now when I start talking, you're watching your own voltmeter and I start toggling this circuit to ground, you see that duty cycle I'm commanding, right? Make sense? The feedback is kind of the same way. The feedback is I push the voltage down to you, I tie my voltmeter to it, I'm watching my voltmeter, and you start toggling it to ground. That's your information back to me. The voltage and the communication come from opposite directions. And by the looks on your face, you guys, this is no big deal to you guys, right? This is what makes a Ford so different and not understood by technicians. It's completely different. So really in the sequence of events, and we'll see some on this, in the sequence of events, remember I said when you go key on, you do soft start. So initially you came key on, you pushed voltage up to me, I toggled it to ground at a 3% duty cycle at 125 hertz, that's the language, and you guys saw that as soft start. Now that means you preload the rotor, you get ready for this startup cycle. So over here on the feedback side where I'm pushing voltage down to you and waiting for you to say something to me, the first thing you say to me is, I don't speak 125 hertz, I speak 130, might be 135. It's a range, it's a pretty good range. So I go, oh, okay, you don't speak that language, so I go back over here and I start speaking to you at at whatever you told me you speak, right? If you told me you speak, I started at 125, you said I speak 130, so now I speak 130. The PCM changes that frequency based on regulator feedback. That opens up the gap on what regulators you can use, right? Because now the regulator frequency doesn't have to be lockstep exactly this, because the PCM will adjust for it as we go along. So initially in diagnosis, we're going to do all the same checks, right? I don't need to go back through those slides again. It's the same stuff we talked about before. The codes that afford sets, you know, the ones that matter, 620, 622. These are the ones we get phone calls on daily, do we not? And guys really don't understand what's going on here. The other codes, again, they generally accompany those two codes. How they work, Gencom. This is back probing the Gencom, just like we did the L circuit for GM. Key on, engine off, 3% duty cycle, and whatever that voltage translates to. Low load, 44%, high load, 50%. But remember, and I always have to stop and talk about this, what happens when it's happy?
No signal.
No signal at all. Now the problem is, if you're a technician, is your application, the tool you use, all vary this. If you're looking at it with a voltmeter, it's pretty cut and dried. It's going to show 100, full duty, it's going to be a full voltage, right? Because remember, the voltage and the signal are at opposite places. So if you're pushing voltage to me and I quit talking on that wire, where does the wire go? Stays high, 12 volts. So if I'm not talking, you'll see 12 volts on that wire. But when you pull up a scan tool will show it as 0. So it confuses a lot of guys there in that what you actually read versus what you see on a scan tool may not be the same thing. And then scan tool makers may do it different. There's a lot of weird things that can happen here. But if I'm not talking, I'll be at 12 volts. The monitor circuit, so key on, engine off. We got a preload, really nothing's going on. You start it up, I get a feedback from the alternator, and as you add load, the values go up. Again, it's just as cut and dried as any of them are. You back probe the wire with your voltmeter, if you want to do it with a plain old voltmeter. Voltage ought to come up as you add load. It is that easy to diagnose a Ford. Now, least understood system I said earlier, but it's simple to diagnose, right? Now, the other thing you can do is the alternator good or bad? You can just unplug it and force it into fail-safe, right? Unplug it, start the car up, rev it up, auto charge it. How much voltage? 13.8. I was just seeing if anybody was listening to me or not. Auto charge at about 13.8. Couple looks at how it operates, just a couple graphs I pulled out of the other presentations we use. This one's meant to just show you how startup works, right? 3% duty cycle, very low duty cycle. This goes from no start to the vehicle's running and how hard the alternator's working in there to maintain that. I pulled this graph to show you, here's a case where the alternator is working really hard, right? The feedback is really high. The alternator's working its tail off, but the PCM wasn't talking because PCM had been happy up to this point. But the PCM sees this going on and it says, well, I better make a new command. And so it started a new command where it said, I need you to bring the voltage set point up. Common graphs. These are common signals you see. Here's my favorite part because I'm going to say again, Fords are the easiest to diagnose once you know how they work. That whole business about voltage coming from one place and the signal at the other, this is the reason it's that way. If you unplug the regulator connector, jumper the two pins together, I think I say with a fuse jumper it should say, right, protect the circuits. But if you just jumper Genmon, Gencom together, now the voltage is coming from one to the other, right? Because that voltage signal thing. So you go to your scan tool, you pull up PIDs for Genmon, Gencom. What do you think they're going to do?
It's going to be the same, right?
They're going to be the same. Because on the command line where I'm talking, the voltage is coming out of myself on the monitor wire up to here. But I think that's you talking to me, right? So I grab that wire and I go, hey, I want you to charge at 14 volts, whatever that duty cycle is, right? Well, what happens over here on this side of that circuit? Because over here, I think this is you talking to me, right? But the truth is I'm talking to myself. So I got a voltmeter tied to this one, and what do I see? The same thing I did over there, right? Okay, so now on this side of the circuit, I go, hey, I want you to charge at 14 volts, whatever it is, 20% duty cycle, just making the number up. Over here, what do I see? Come on, give me the answer. I see the same thing, 20% duty cycle. Okay, so over here, where I'm watching that too, right? And over there I see a 20% duty cycle. I commanded a 20% duty cycle. What am I going to do now? I'm going to quit talking altogether, aren't I? Yeah. Okay, so this is the part that gets confusing, and it's the reason that I drag it out this way. So over here I go, hey, 20%. Over here I see 20%. So over there, what do? I just shut up. So over here now what happens?
You should have.
Oh crap, that's not right. So back over here I got to start over again, right? Because that's not doing what I said to do. So over here now I'm going to go, hey, 20%. And over there I'm going to see 20%. And then over here I'm going to quit talking. So what I mean by that, and the reason I dragged that out, is that's what the PIDs are going to do, right? You're going to see Genmon and Gencom go up to some value. I don't know what it's going to be. I don't really care. But then they're both going to immediately fall back down. So that confuses guys even worse. As long as you're aware of that, and you see the two PIDs go bam, 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 and one will actually go right before the other, and then the other goes, and then it falls down, and then it falls down. And so the constant fluctuation confuses people. But what does that tell me about the entire circuit? Everything from the alternator through the PCM, including the PCM's ability to calculate that stuff, is doing exactly what it's meant to do. Both circuits, alternator back. Is that not the easiest to diagnose there is then, really? I mean, to me, that's what makes the Ford neat. It's weird, the whole voltage communication thing, that people really don't understand that, or it's not explained well. But the cool thing about it is once you grasp it, man, diagnosis is a cakewalk. So I unplugged the alternator, I start it up, I rev it up. The alternator ought to go to 13.8, right? That tells me I got a good rotor, I got a good stator, all those kind of things. Now I jump these two leads together, I go look at my scan tool, and those two PIDs sit there and do this. This car's doing everything it's supposed to do at that point, right? That's what makes this system kind of neat. To add to that, the slides that do remain for Ford are voltage drop slides. So we've talked about this already, right, with GM, right? Engine running, loads on, within half a volt. Here's the thing, I don't know about Ford overseas, what their products are like, but I can tell you domestic Ford, and I'm a Ford guy, so, and I'm about to badmouth their product, this will fail every time. It just, every time is always dangerous, right? But this is the failure in Fords. Ford likes to use fusible links. Those fusible links are failed in Ford over and over and over. Our tech line guys, they take this call, this problem every single day on Ford applications, do you not? Every single day they take this call. It's the B plus to the sense line, and I'm going to hit the sense line with the next slide. Fords are notorious for this failure. So because they use a fusible link in this range, right? This is obviously just a graphic I pulled up, but there'll be fusible links in this range. I don't know if a lot of the European stuff uses fuse link, but for Ford, one of the things that makes it different, looking at that 3-pin connector, is the first one over here, the one closest to the B plus post, is a sense line for this application. If you go back in history for Ford, that was an A circuit's what they called it, and it was actually the current for the rotor, which was different from other manufacturers. But that circuit has the very same problem. So, you know, this one, if that's more than half a volt, you got to go check them, right? And I won't go through how to check positive, negative. We've talked about that. But the same thing applies. You've got to hit the sense line the same way. Engine running under load, flowing all the amperage you can, that sense line has to be within half a volt of the battery too, because it also goes through a fusible link. Those are notorious places for Ford failure, just notorious places. Worse for us then, and the place that the amperage slide fits into this one, my favorite application to talk about is Ford diesel. We take calls daily on Ford diesel. I don't know about daily, but very frequently, especially the 6-liter family, where they're sitting at idle and they're at 12.5, 13 volts, and the customer thinks it's not charging. And if I'm answering that phone, when I'm in the engineering lab, I'll answer the tech line phone along with the tech line guys. I'll get that guy who'll call in with this application and he'll say, I've put on 3 alternators and it's still not charging. So the first thing I say to him is, hey, reach out and touch the alternator, tell me what it feels like. And you hear him scream because that alternator is as hot as it can be. Because the diesel applications use either an IDM module or a FICM module to run the fuel injectors. Requires a lot of amperage. At idle, the alternator will not produce enough amperage to overcome the truck. Between the glow plug system and the injection system, they ask for something in the neighborhood of 70 to 80 amps at idle. It's about all the alternator can make at idle. And so you see the voltage fall off. So a technician that's trying to diagnose charging system strictly with a voltmeter, he wants to put 3 different alternators on this truck before he finally calls us to say, your alternator doesn't work. No, it's working perfectly. It's doing exactly what it's supposed to. And you can tell because you got burn marks on your hand now, right, that says that alternator's working really hard. So you can use that to hang somebody out to dry if you get the chance. Just tell them to touch it and tell you what it feels like. But it's the technician's fault for not checking amperage, because he would see that thing's putting out 60, 70, potentially everything it can put out. And when it does, the voltage collapses, right? When you max the alternator out, the voltage goes away, right? It's the trade-off for wattage.